Life has always found a way to survive. For much of Earth's 4.5 billion year history, life came in the form of single celled organisms, like algae, happily floating in the oceans, photosynthesizing carbon dioxide into oxygen. But in response to the changing world around them, the algae could no longer continue to do what they had always previously done, and after billions of years of evolution, multicellular life developed. This landmark moment's exact timing is debated, but happened roughly within the last billion years. At this point, life began experimenting, evolving into the most unusual and weird organisms imaginable. No one knew the most effective way to live, or what environments to move to, so life tried to adapt to every nook and cranny it could. But only the most effective survived, creating societies in life friendly environments filled with the most efficient life forms for each niche, such as the fastest growing plants and the most deadly predators. After millions of years of bizarre organisms, life eventually settled down, no longer trying outlandish designs. Instead, they evolved into a fairly normal looking collection by 540 million years ago. By this time, the Earth also began to resemble the Earth today, with many similar environments and atmospheric conditions. However, it's not been a simple and smooth ride from the Cambrian until now. There have been many ups and downs along the way. An extinction is when the last living member of a species perishes, so the species is no longer represented by living organisms and can only be found in the fossil record. And a mass extinction is where an extinction occurs in over half of all living genera, including all living things like mammals, fish, plants, and insects. Genera is the rank above species, so with humans being Homo sapiens, it's the Homo bit, and would include Homo erectus and Homo neanderthalensis. Extinctions are not rare events, they are always happening with species disappearing, but usually the rate of extinction is matched or exceeded by the rate of new species being created. So normally, extinctions are not noticeable. But a mass extinction only occurs when the rate of extinction massively exceeds the rate of new species evolving. Over half of everything Thanos snapping away sounds impossible, but has actually happened 5 times in the last 540 million years. The big 5 mass extinctions are the late Ordovician, 445 million years ago, the late Devonian, 373 million years ago, the Permo-Triassic, 252 million years ago, the Triassic-Jurassic, 201 million years ago, and the dinosaur-ending Cretaceous-Paleogene, 66 million years ago. The late Ordovician. The first of the mass extinctions occurred about 100 million years after the explosion of multicellular life, and occurred in 2 phases, freezing and melting. During the first phase, glaciers rapidly grew to cover Gondwana, a continent made up of South America, Africa, India, Australia, and Antarctica, and straddled the South Pole. Due to so much water being locked away as ice, sea levels quickly dropped, causing any life in the shallow seas and on coasts to lose their habitats. Since most oceanic organisms live in the shallow water, the rapid destruction of these environments caused untold damage to life in the oceans. But some life managed to adapt and create new ecosystems in the colder water. Quickly, however, the ice began to melt and sea levels rose again, but things did not return to how they once were. The new water was depleted in oxygen, so was anoxic, meaning returning organisms couldn't breathe in the new shallow water environments. Instead, organisms that don't need oxygen moved in, producing massive amounts of toxic hydrogen sulfide, further making the shallow waters hostile. The cooling phase was a result of the appearance of land-based plants removing CO2 from the atmosphere, and the creation of the Appalachian Caledonian mountain range that created a lot of new rock that rapidly rusted, removing even more CO2 from the atmosphere. And the melting phase occurred in response to an increase in global temperatures by about 6 degrees Celsius. The cumulative impact of both phases led to the permanent extinction of 85% of all species and 57% of all genera, making it the second largest mass extinction. The late Devonian. The next mass extinction occurred 373 million years ago, but was quickly followed by another major extinction event that only made things worse for life, culminating in a loss of 50% of genera and 75% of species. It was caused again by global cooling, as plants underwent massive evolutions that allowed them to increase their maximum height from 30 centimeters to 30 meters. This allowed plants to colonize more arid regions, and the development of seeds allowed for plants to spread wider and further into continents, increasing the amount of photosynthesis, resulting in cooling. Taller trees also means deeper roots that broke up rocks that then get rusted and remove CO2 from the atmosphere, again causing cooling. These broken rocks then get carried by rivers to the sea and dump massive amounts of nutrients for coastal organisms to consume, but this massive dumping leads to eutrophication, the massive overgrowth of life using all available nutrients, including oxygen, resulting in a high rate of decomposition as the bloom ends, and eventually anoxia. There was also significant volcanism at the time too, as Siberia and Russia were splitting apart. But for mass extinctions, the volcanoes aren't normal volcanoes. The eruptions happen in fissures, continent-sized cracks in the Earth's crust, through which basalts flow for hundreds of thousands of years, covering continent-sized areas known as flood basalts. During the late Devonian, erupted lava covered an area of 320,000 square kilometres, as more than 1 million cubic kilometres of lava poured out of the fissure, and with it erupted massive amounts of CO2 and SO2 into the atmosphere, destabilising ecosystems and habitats. The Permo-Triassic. The largest and most devastating mass extinction occurred 252 million years ago, marking the boundary between the Permian and Triassic periods. 83% of genera went extinct, and for the first time, both land and marine organisms suffered almost equally. The main cause was volcanism, as flood basalts flowed out of the Siberian traps. The lava that flowed out covered over 2 million square kilometres of modern-day Russia, and with it, many gigatons of SO2 and CO2 were released into the atmosphere, causing significant and rapid climate change. The amount of CO2 released increased the atmospheric CO2 parts per million levels up to 8,000 ppm, and for reference, at present, it's about 420 ppm, which led to a 17 degrees Celsius temperature rise globally. Carbon dioxide does more than just make the world hotter, it also dissolves into the oceans, reacting with the water to create carbonic acid. And even the smallest changes in ocean acidity could have major impacts on marine organisms. Almost overnight, a creature that had dominated the oceans for over 100 million years was brought to the brink of extinction, while a similar species rapidly grew to dominate the seas, due to their differing dependence on acidity. Also, by CO2 dissolving into the oceans, it means that oxygen is not, making the oceans anoxic. The Siberian traps also released halogens that damaged the ozone layer, allowing more radiation to reach the Earth's surface and damage genetic material, and released aerosols that blocked out light and created something similar to a nuclear winter. The flood basalts, after covering the Russian continent, eventually flowed into the ocean, disturbing the seafloor and releasing enormous amounts of methane that had built up over millions of years as fish fell to the seafloor and decayed, further increasing global temperatures by 6 degrees Celsius. At the same time, Pangaea was at its peak, so the length of coastline was at its lowest, and the vast continental interior was at its largest, leading to a massive arid desert in the centre of the continent, much like the Gobi Desert, but on a global scale. The Triassic-Jurassic. And just 50 million years later, the next mass extinction occurred, at the Triassic-Jurassic boundary. Again, a main cause was flood basalts, but this time as Pangaea broke apart and the Atlantic Ocean opened up between the Americas and Europe and Africa, called the Central Atlantic Magmatic Province, or CAMP for short. The flood basalt had similar effects to the Siberian traps, releasing so much CO2 that it quadrupled atmospheric levels from 1300 ppm to over 5000 ppm, at the fastest recorded rate in history, releasing aerosols that led to brief global winters, and widespread oceanic anoxia and acidification, while also releasing massive amounts of mercury into the atmosphere, poisoning any organisms that breathed it in. The rapid climate changes in massive continents increased the rate of natural disasters and weather events, like lightning and wildfires, that led to the degradation of soil to the point where plants could no longer root themselves, so could no longer live in many environments. All this resulted in the demise of 76% of species, impacting both on land and in the oceans. The Cretaceous-Paleogene. The most recent and most well-known mass extinction marks the Cretaceous-Paleogene boundary, where the dinosaurs went extinct 66 million years ago, along with 75% of all species. A driving cause behind the event is the very well-known meteorite that struck the Earth just off the coast of Mexico. The meteorite created a mega tsunami that had waves 100 meters tall in shallow seas and 4.6 kilometers tall in deep seas that would have flooded all low-lying areas across the globe. The material thrown up into the atmosphere from the impact created holes in the ozone layer, allowing for an intense pulse of radiation that cooked the exposed organisms while also creating widespread wildfires, and then creating a long-term winter as the material blocked out sunlight. Due to where the meteorite landed, sulfur aerosols were also thrown up into the atmosphere, creating global acid rain and ocean acidification. Simultaneously, flood basalts were erupting in India from the Deccan traps. The volcanism had similar impacts as before, releasing enormous amounts of CO2 ocean anoxia and acidification, and releasing aerosols and halogens. However, below the oceans, the amount of volcanism was actually decreasing, causing submarine volcanoes to sink, causing sea level to drop, and the loss of many shallow sea and coastal environments, but none of these come close to the greatest mass extinction in the Earth's history. We will have to wait until next time for that.